Here comes an object from outside the solar system, and it shows anomalies. The scientists would say we should be as careful as possible at talking about anything other than a rock. Now, they say that when they know that humanity launched a lot of space junk, a lot of technological objects to space. And we also know that there are 100 billion stars like the sun in the Milky Way galaxy alone. Most of them formed billions of years before the sun. And there are billions of Earth-Sun analogs. Now, we all believe that we came out of a soup of chemicals. That's the scientific narrative of how human intelligence came on this Earth. And so it's quite likely that, we are not the first one. Sorry to break the news, Elon Musk was probably not the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago. And therefore, we should consider the possibility that things like us existed long before us. And you can ask the question, how long does it take our own technology, the Voyager spacecraft that we launched out of the solar system, how long does it take it to move to the opposite side of the Milky Way galaxy? Thousands of light years away, takes less than 1 billion years. And that means that all these civilizations that had their history initiated billions of years before ours could have done it. And all we need to do as responsible scientists is to check if among all the rocks that come from outside of our backyard are really rocks. Or maybe one of these objects might be a tennis ball that was thrown by a neighbor. And the reason I say that is, we live at our home, on Earth, next to the sun. We look around us in the cosmic street, and we see a lot of houses just like ours. There are billions of them, probably. Now, my colleagues, those scientists who think traditionally, they say, microbes came to Earth very early, therefore they must be everywhere. So let's define our highest priority, searching for microbes on other houses in our cosmic street. And I say, good, you can do that from the vantage point of your home. You can look through the window and search for microbes in your neighbors' yards. But you would need to put $10 billion to develop a big enough instrument that would be able to detect the chemical fingerprints of microbes, on exoplanets. And think about the possibility that there is a resident in one of those houses. That resident might show up in your front door at some point, or you might see an object that arrives to your backyard or your mailbox from that resident.
A black swan event.
A black swan event. Or you might see some construction project from a distance. That might be easier to detect than microbes. So we should hedge our bets. We should invest billions of dollars on both fronts. At the moment, the scientific community is willing to allocate more than $10 billion to searching for microbes, but no recommendation is made to allocate any federal funding to the search for intelligence. And I say that is an oversight.
Let's go back to, one more time. Oumuamua. Okay, yeah. I don't want to screw it up. How large was that?
That was the size of a football field.
So
of all the 100 meters.
Small in comparison to 3I Atlas.
Oh, yeah. That's my point, that 3I Atlas is 1 million times more massive, at least 1 million times more massive than Oumuamua. Right. And I immediately, as it was discovered, it was July 1st, and my wife asked me to go on vacation to Aruba 2 days later. And as I was going on the plane and as I arrived there, I realized, wait, that doesn't make sense because we should have seen millions of Oumuamuas before we saw this one. It's so big. And I also realized there is not enough rocky material per unit volume in interstellar space to deliver such a giant rock into the inner solar system within a period of a decade. You would expect it at the very optimistic scenario where you package all the material into objects that are 5 kilometers in diameter. You would imagine once per 10,000 years. So I wrote immediately a scientific paper. My wife was not happy that, on our vacation, I was sitting on my computer, but I just couldn't resist it.
Right.
And by the way, this paper I submitted for publication. That was July 3rd or something. And then the editor said, oh, the paper is fine, but you have a concluding sentence at the end where you say, well, unless the object is smaller than estimated, maybe it was targeting the inner solar system. That was my solution to say, one way out of this dilemma of why is it so big is if it was targeting the inner solar system by design. And indeed, the trajectory is aligned with the plane of the planets around the sun to within 5 degrees. The chance for that at random is 1 in 500, okay? And it's moving in a retrograde trajectory opposite to the motion of the planets, which is ideal for it to release mini probes that will get into the planets. It gets close to Mars, it gets close to Jupiter, it goes on the opposite side of the sun relative to Earth when it's closest to the sun. And that's the time when a spacecraft could do a maneuver to take advantage of the sun's gravitational assist. All of these are interesting indications that may imply that some intelligence designed the trajectory. So I had one sentence at the end of the paper saying, maybe the trajectory was designed. And the editor said, no. The paper will not get published unless you remove that sentence.
Wow.
So now when you listen to comet experts that say, well, this claim or that claim was never published in a peer-reviewed journal, guess what? They are the editors or the reviewers who are blocking the discussion on possibilities. And I think it's inappropriate, especially in the case of alien technology, because it could be a black swan event. It could be something that affects the future of humanity. And if we behave, very conservatively, we might not last very long.
Well, it's also arrogant.
It's arrogant.
Yeah. This object shows that there's no iron.
Oh, no. So then the composition of the plume of gas around
this is before you knew about the composition.
That's right.
That you wrote this paper.
Exactly.
Okay.
And
so as time is going on, you are being shown to be correct.
Well, we found more anomalies.
More anomalies. So this is not a normal thing.
Not a normal thing. So for one thing, there was a glow that looks like an extended feature. And everyone said, oh, that's a tail. That's the signature of a comet.
Right.
And I said, wait a minute. It's pointing towards the sun. It's not pointing away from the sun. Usually cometary tails are made of dust and gas, which is pushed back away from the sun by the radiation and the solar wind, and so this one was pointed towards the sun, not away from the sun. And the question is, why? And actually, I calculated that, it appeared very clearly in the sharpest image we had from the Hubble Space Telescope, which showed an elongation by a factor of 2 towards the sun. But we were looking at it like a cigar. We were looking almost along the cigar long axis, within 10 degrees of the object sun axis. So we were looking almost edge on. Mm-hmm. And I calculated if you were to correct for that, this would be a feature that is 10 times longer than it is wide, and that means it's like a jet. So the object had a jet in front of it towards the sun. The question is why? And, the comet